Hey everyone, I'm just finishing up here our lesson on multiplying with polynomials, which we got a pretty good start on. Let's see. There we go. So our objectives here in this lesson were really to basically a lot of multiplying and just multiplying different things by different things, multiplying two binomials, a binomial and a trinomial, two trinomials. They all really work the same way. So here's a quick overview of what we did when we were in our live session. We practiced multiplying a binomial by a binomial, and I kind of described it as a distributive property on steroids, because we're going to distribute everything in the first polynomial by everything in the second polynomial. It just takes a little bit of staying organized. When we're talking about squaring polynomials, well, it works out the same thing, because we would have a plus b times a plus b, but it just forms this really, really neat pattern. And then we talked about how we're able to identify some perfect squares in later in a couple of lessons. What we started to do was talk about multiplying a polynomial by a polynomial. Now, I know the objective said that we were going to work on multiplying two trinomials, but I think we're just going to generalize this a little bit more and look at multiplying a polynomial by a polynomial. So as I mentioned, I think of all this polynomial multiplication is just really super use of the distributive property, or what I called it, the distributive property on steroids. Probably not politically correct, but the idea is always going to be the same. It's always going to come down to monomial times monomial, where we multiply the coefficients and then use the product of powers property. So let's take a look here at our first one, which was actually a binomial times a trinomial. Now I know we did this one in class, but I did it really, really fast. So I'm going to try and do it a little bit more slowly. So the first idea is that we're going to distribute this to here. So that's kind of going to be our first step. So we'd have a times, and I'm just going to rewrite this polynomial, 2a squared plus 3a minus 7. Then I'm going to distribute this through this. So now I will have negative 4 times 2a squared plus 3a minus 7. Now it looks like we have two sets of distributive properties. So I'm just going to draw in my arrows here, distribute this to that, and that, and that, and the same thing over here. And remember this negative sign. Just like that. So now I'm going to do the 4 steps of monomial times monomial. So I'm looking at a times 2a plus a times 3a. Oh, sorry, a squared over here. 2a squared minus a times 7. Then I'm going to have minus 4. Actually, I should do that in a different color so you can see where it's coming from. Minus 4 times 2a squared minus 4 times 3a and minus 4 times negative 7. Just distribution. Just happens to be a lot of distribution. So now we are going to separate out our coefficients and our variables. Fortunately, we don't have a lot of coefficients in this first set, so the coefficient part is going to be pretty easy. So we have 2, that's our only coefficient, times a squared. Then we have 3 times a minus 7 times a. Now, in this blue section, we do have more coefficients going on because we have that constant that came from the negative 4. So we have negative 4 times 2. So I'm going to say minus 4 times 2 times a squared. Then minus 4. I'm not going to put the parenthesis there. 4 times, actually, I probably should. 4 times 3 times a, and then minus 4 times negative 7. And now we just start simplifying, combine the coefficients, and then product of powers property. A to the first times a to the second is a to the third. Plus 3 times a to the first times a to the first becomes a to the second, minus 7a. Now to the blue side, we have minus 4 times 2, so that's a minus 8. And only one variable, we don't have to do anything there, a squared. Now minus 4 times 3 is 12. And again, just one variable, so no changes there. And then minus 4 times negative 7, negative 28. Okay. Now let's write this. I'm going to take these parentheses out of here because I don't think we really need them. So now we want to start combining our like terms. Remember, our like terms are when we have the same variable with the same exponent. So I only see 2 situations like that. I see we have an a squared here and an a squared here. And then we have an a over here and an a over here. Notice how I'm not worrying too much about the coefficients, because that's going to come when we do the actual combining. So now at this point we could move things around so that all the things that are to the same degree are together. Or since I've got them color coded, I'm just going to leave them like this. But we get 2a cubed plus, see, 3a squared minus 8a squared. Gotta change that to a minus 5a squared. Then a minus 7a and a minus 12a. So that's a minus 19a. And then a minus negative 28 becomes a positive 28. Let's check to make sure we have this in simplest form. Checking our degrees here. So let's see, let's find a real good, nice color. I'll use orange this time. So our degree here is 3. We've got a degree of 2, degree of 1, degree of 0. So it looks like everything is written the way we want it to be. So we have found our product of a binomial times a trinomial. So in our live session, I did that pretty quickly. I hope I slowed down a little bit for this one. Let's take a look at multiplying 2 trinomials. Again, the process is going to be exactly the same, except we're going to do it 3 times instead of 2. So we're going to do things like distribute this through all that stuff. Then we're going to distribute this through all that stuff. And then we're going to distribute this through all this stuff again. So let's see if I can keep these colors going. I hope I can. like my big fat marker. So I'm just going to write this as I'm distributing it. Change it to a monomial times a trinomial. So I'll have x squared times 2x squared minus x minus 1. And maybe I should use the fat marker. So let's see, where's my blue? I'll keep it for this row. So I've got plus 6x times 2x squared minus x minus 1 plus, here we go, plus 9 times 2x squared minus x minus 1. Now it's looking a little bit more familiar because we know how to deal with a monomial times any kind of polynomial. Simpler distribution. So now we have x squared times 2x squared plus x squared times negative x plus x squared times negative 1. And then we have plus 6x times 2x squared plus 6x times negative x. I know this is kind of repetitive. Plus 6x times negative 1. And then our orange set plus 9 times 2x squared plus 9 times negative x plus 9 times negative 1. Phew, made it. Okay, now we just have a whole bunch of monomials times a whole bunch of monomials, which I think we can handle by now. I think I might skip a couple of steps here. I think I might go right to this being 2x to the 4th. Excuse me. And this I'm going to go to a negative x cubed. No coefficients, but we do have that negative x, so I have to change the sign. And then this last one would be a negative x squared. Multiplying by the negative 1 just changes the sign. Then in the blue section, let's see, multiply the coefficients. So I get 6 times 2, that's 12. X times x squared, that's x cubed. Plus 6 times, let's say 6 times negative 1. That becomes a negative 6. So I'm going to change that plus to a negative 6. And x times x is x squared. And same thing on the last term. That's a negative 6x. And then in the orange section, where is orange? There it is. I've got 9 times 2x squared. How about that being 18x squared? And I've got 9 times negative x. How about a negative 9x? And then a negative 9. Excellent. I'm almost out of time already. I can't believe that. So I'm just going to mark where our like terms are. Let's see. How about I start with the x cubed. There's an x cubed. There's an x cubed. And that looks like it. How about our x squares? Here's an x square. Here's an x squared. Here's an x squared. That's interesting. And then our x's. Here's an x. And here's an x. Whoa, can't see that. Wasn't expecting that. I'll just give it a big fat circle there. And notice we have no x to the 4ths anywhere else, and no constants anywhere else. So now, when we come back, we'll just start combining these and find out what